Let's do it. -2 square root 20, right? And they just want us to simplify it, right? So what's the largest perfect square that goes into 20? That's good. Give me a perfect square though.
4 and 5.
4 and 5, right? So this becomes -2 square root 4 times square root 5. And the square root of 4 is 2, right? So -2 times 2 square root 5.
Square 5.
So no, -4 square root of 5. And then that's it. That's the answer to that question. 2 times 2. Yeah. So type it in. Right.
But that's for 4 and 5.
Because of the 20, I could break down the square root 20. Type it in and see.
No.
That's you. I got you. So the square root 20 get broke down to this, and then this is just down.
Yeah, just try to memorize it, because it's like difficult to understand the why.
Yes.
In my opinion, I don't understand why this is done.
Gotcha.
I'm really very good on copy. So we gonna be doing it by hand as a touch, for how long? How long?
An hour and a half?
Yeah.
Yeah.
How many questions?
It's a good question. Was it like 30 or something?
30, 20.
Something like that. Yeah. Nah, all open-end questions. Yeah. I mean, there's word questions on there and stuff like that. Yeah. Yeah.
The word questions are pretty tricky.
Nah, they simple. They simple. Yeah. Yeah. I mean, but you've seen the test already. It's the homework. All I did was copy and paste the homework. Yeah, yeah. You know how hard it is to make a test? I ain't got time to.
You copy and paste from the homework. I would need like 3 hours, that's how long it takes.
For real?
Yeah.
But I'm only doing like one question from each section. Yeah. Yeah. And I gotta choose the easy question because you see how many of y'all there is? Like
Do you know how long like attempting myself?
Exactly.
You do it, and then I gotta go cheat on ChatGPT, and then I gotta write down ChatGPT.
but I like the fact that you get to attempt to get it wrong and get no penalty. Like that. That's all. Yeah. No. Yeah.
What you think?
Yeah. Yeah. Right. Partial credit if the answer is like wrong. Yeah. Yeah. So that's the advantage of showing work. Any other questions though? Anybody has? Yeah. Okay. Got you. Got you. Were they radical questions like this?
Yeah, it's kind of like they had the alphabet.
Oh, they had the alphabet in it. Okay. All right.
The funny, with the funny X, no. What question you from? It is called homework 9.
Homework 9. Okay.
The other? It was a little bit harder than what we did yesterday, so.
Number 8. So number 8, after.
What was it like? Like I'm gonna just. Yeah. It was. Was it like this? Like what is x squared equal to 16? And then you square root both sides. And then you have x is equal to 4 and x is equal to -4. Like that. Okay. Okay. That was part of the homework though. Yeah. Oh, you mean the radical with the fraction? Yeah, that's what we did at the end of class. Yeah. But that's actually like really easy though. You just multiply by the denominator. Yeah. By whatever's in the denominator. Yeah.
Put the whole number over a one, that's it. And then you proceed to multiply.
Like this, right?
Yeah.
Yeah. So you just put the radical over both of them individually,
Oh, that's
right?
complicated, teach.
That's not bad. That's not bad. Look, so this becomes what? 1/√2. And then to get rid of the radical in the denominator, you multiply by the radical denominator, which use a bond you do to the top. Multiply straight across. Final answer is just this. Radical 2/2. Simple.
Oh, no, oh, okay, my bad. The fraction was outside and the whole number was inside. That's why I said
Yeah,
just
that's
put the
what
whole
I said.
number
Oh, but
over a one.
Oh yeah, yeah,
Then
yeah.
you multiply.
Yeah.
Sorry.
That's not too bad. That's
No.
even easier than this one. Yeah. Yeah.
Believe it or not.
Mhm. Sorry. A number. So, but it could be like a positive number or negative number. Yeah. So -3 is an integer, +3 is an integer, etc. Nobody else with questions? Everything was easy? It was difficult?
Professor, is that a trick question?
Not for real.
You
For
messing
real,
with me.
yeah. I mean, I know that the homework is a little skimpy though. Like, I know I could do better on that. Yeah. Cause no, because don't y'all only have like 3 questions for homework? You said that's yeah, okay.
I've come to the conclusion
Mhm.
that maybe
Yeah.
my other teacher is,
Really?
please don't hate me.
From that much homework? Man, I got you.
What do people after a while? You know, yeah.
So which question you got, Roman? This a long question?
Yeah,
Why should be mad easy? Let me see.
I believe more.
All you gotta do is just do these.
I did all that, but
So
kept getting them wrong.
It's
30 times 30 times 30.
Yeah,
So,
it's 30 and 3.
so I didn't do 30 times 2. It says you can.
Like which one?
Like right here. I would
24?
do 24 times 2.
It was 30.
No. Look.
That was the final.
So all right, let's say just for conversation reasons, right? You don't know what is the largest perfect square that goes into this, right? So all right, you could start off with the way you said, right? You want to do like 12 times 2, right? That's fine. That's fine. 2 is a prime number. That's what I'm looking for. But you could keep breaking down to 12, right? So we could go further with the 12. Let's say we're gonna do 2 times 6. We could keep breaking down that 6, right? This is 3 and 2. All right. What you want to look for is you want an even number of duplicates, right? So you see how I have 2 2s right here? That means that I could do something like this: 2 to the second times 2 to the first times 3 to the first, right? These ones that have the 1, those are gonna stay under the radical, right? But remember that the square root is low key like a denominator with 2. So this and this one are going to cancel out. So when I do square root of 2 squared times square root of 2 times square root of 3, these will cancel, right? And this is just going to become a big 2. And then put these together, 2 times 3 is just going to be Square root of 6 like that.
That's a lot of stuff just for me to put in.
I'm doing that because like I'm showing you why. But to be honest with you, like in practicality, right? I saw a square root 24, I would have been like, oh, 4 goes into that. So this is what? Square root 4 times square root 6. And the square root of 4 is just 2 square root 6. It's only 2 steps, but I want to explain to you why it was, you know?
Okay.
Yeah.
Cause all I was doing was just multiplying until I got the right number, but when I got to these down here,
Yeah.
it was just like.
Even that one that's crazy with the 27,000 or whatever, right? Low key, you could just break out 10,000 times 27, right? Square root of 10,000 is something real simple. Square root of 27, you finish that out, multiply that times the 9 or whatever. You good. Or the 3. Yeah. Yeah. Just remember that you could do it in steps. You don't have to know the initial perfect square. You could do a smaller perfect square and just keep doing it so you can't know more. And then you get the final answer. Yeah. Any other questions, anybody? You good? All right, let's do it.
Just like that. Same. She's a liar.
I feel like she'd be good in class. Like she don't have no questions or nothing. Yeah. Like,
Yeah, whatever I put just came out wrong.
They have no issues.
degrees? Oh, add them up and divide by how many numbers are.
Okay,
So
so
you do it.
it's 5 by divided by 5, right?
Exactly. Yeah, and then that's it.
I have to put
Yeah.
that circle, that Fahrenheit.
Nah. It's already there, see?
No, I actually had to copy
Yeah.
and paste it from Google.
Yeah, she, that's actually what we're gonna do today. Yeah. All right. All right. You see? Oh.
Listen, I did it wrong, ChatGPT did it wrong, or you did it wrong, you got it wrong too.
Ooh, that's mad easy. Plug in 4 for B, plug in 8 for H, a little bit of math, and then write the answer.
So I'm multiplying.
Yeah, 1/2 times 4 times 8. Yeah.
Cause I just feel like I'm multiplying things I'm not supposed to, and that's what I'm getting wrong.
I got you. B stands for base and H stands for height. Yeah, so that's right. Yeah. Yeah.
Like, based on.
Yeah. Yeah. Just like the formula. Mhm. Cool.
Doesn't have to be. All
right.
Divide based on stage.
If the question tells you, yeah. Yeah. Like they give you like they would probably give you the same formula, but you'd have like fractions, like for the base and the height. Then there'll be like a division. Yeah. Mhm.
Grandmother vocabulary. And our. I know it's.
Yeah. For most of it. Actually, to tell you the truth, like philosophically speaking, right? There's no such thing as subtraction, there's only addition. And there's no such thing as division, it's only multiplication. You know, when you talk about subtraction, that's just the addition of negative numbers. You know, when you talk about division, that's just the multiplication of fractions. You know? Yeah. 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 So you could legit multiply. Yeah. That's what I'm saying. Like if nutrition don't work out, switch to math. Yeah. I tell you an interesting story. So there's this topic in mathematics. We're not going to learn it here. It's called linear programming, right? This was actually invented for nutrition, you know. So this had to do with like World War times or whatever. So they wanted to ration the food, right? But how much like nutrients do you need, like macronutrients and stuff like that, right? So they invented this math, linear programming, to figure out how to feed the soldiers over in the war to ration the food and all that. Mhm. That, yeah. And each one of those are inequalities and stuff like that. Yeah. Yeah. Yeah.
It's like this, it's like, I don't think we've had enough.
But that this stuff is a piece of that. Like, like that's the precursor to that. Yeah. 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 Right. Mhm. But even when they say a deficiency though, right? What that literally means is like you're eating less than or equal to a particular number. Yeah. Yeah. So a football team is got you. Yeah. So it's nine plus then you're losing five. So negative five, right? And then gains and then plus six. Yeah. Yeah. And then this is the answer. Like 10, that's the answer. Good job. All right. So let's look at what we're getting into today then. All right. So we kind of taking a little bit of a break today. Today's gonna be a real easy class because y'all probably know it all already, to be honest with you, which is fine. You know? Yeah, next week Thursday. You got a whole test. I mean, it'd be like 30. It'd be like 30. Yeah. Really?
Yes, look at this. Yo, this right here is one problem. What?
Really?
Yeah, I have pages like that, too, like five, like this.
You know,
Like that.
you could just use a calculator. Yeah. Really? That's love right there. That's love. Yeah.
If I need it wrong, to show my working efficiency, right? That's right. So I don't always just a whole bunch of numbers on the page.
That's a fair point. Yeah, that's a fair
So,
point.
yeah, 5 questions, cause look.
Mhm.
Like, look.
That's a fair point. But that's why I want y'all to do your homework, you know? All right, let's look at this real quick. Some of y'all probably know how to do this already, so y'all can just do the homework in the meantime if y'all understand. So we're talking about measures of central tendency, mode, median, and mean. All right. See? So all right, finish your homework. All right. So that it was on the regions, right? Yeah. Right. Yeah. Sorry. So the average price of an ounce of gold is 1,350, right? Dollars. The Zippy car averages 39 miles per gallon on the highway. A survey showed that the average shoe size for women is size 9. Is that true?
I'm sorry, what?
Yeah, the average shoe size for women is size 9. Okay. Oh, that's hilarious. She said, oh man. Oh, that was a good one. All right, so look, in each of the preceding statements, right, one number is used to describe the entire sample or population. Such a number is called an average. There are many ways to compute averages, but we will study only 3 of the major ones. The easiest average to compute is the mode, right? So the mode of a data set is the value that occurs most frequently. All right. So if a data set has no single value that occurs more frequently than any other, then that data set has no mode. All right. Mhm. Oh, it is that. It's exactly that.
I think if you
Right?
just simplify it in your own words, it'd be easier. Like for mode, I put the number that repeats the most. That's it.
Yeah, that's how I used to
That,
do it.
keep
That is
it
it.
simple and as cute as you possibly can.
That is it. Right? Matter of fact, since you got it, right? Help me out with this. All right. All right. So count the letters in each word of this sentence and give the mode. The numbers of letters in the words of the sentence are
Is it four? Is
Mhm.
four the mode?
Maybe.
1, 2, 3, 4, 5. Yeah, four is the mode here. So when you see the
Four is the
mode.
mode. It's not three, it's not two.
Oh, it's four.
Okay, good. So scanning the data, we see that four is the mode because more words have more letters than any other number. For larger data sets, it is useful to order or sort the data before scanning them for the mode. So, right, exactly, exactly, right? So that's like a little hint. You don't have to, but if you put it in order from smallest to largest, the mode will just like pop at you, you know? All right.
Either way, it has to be in order for you to find the one in the middle.
Exactly. Exactly. So that's the mode, right? Let's talk about another one. Y'all probably even know what this is too. So we just
Like thoroughly, but I remember a little tiny.
what's the median? Let me see if you remember.
It's the median when you add everything and then you
Nah.
divide it by.
No, no, middle, no, middle is the middle.
And if it orders, I don't know.
From least to.
Very good.
least.
You got it, right? So not every data set has a mode. For example, if Professor Fair gives what the I'm sorry. I have a pop-up on my screen with Prince Harry. I don't want to see Prince Harry right now. Oh my God, why is it opening? Oh my gosh. Right. All right.
It's the one I said.
Uh-huh.
The mean. Oh.
Yes, that's the mean, right? So not every data set has a mode. For example, if Professor Fair gives equal numbers of A's, B's, C's, D's, and F's, then there's no modal grade. In addition, the mode is not very stable. Changing just one number in a data set can change the mode dramatically, right? However, the mode is a useful average when we want to know the most frequently occurring data value, such as the most frequently requested shoe size. Another average that is useful is the median, all right? Or the central value of an ordered distribution. So when we are given the median, we know that there are an equal number of data values in the ordered distribution that are above it and below it. So here's a procedure on how to find the median, right? So the median is the central value of an ordered distribution. To find it, you order the data from smallest to largest, all right? Also, you can also order it from largest to small as well, right? That doesn't matter. But for me, it's just easier smallest to largest, right? For an odd number of data values in a distribution, the median is simply just the middle number and we're done, right? Mm.
But
What's that?
sometimes there is no median.
There's always a median. Yeah. Sometimes there's no mode.
Why?
Yeah. Because it's just the middle number, you
Okay.
know? Yeah. So if it's an odd set of numbers, right? Right. Got you. We gonna talk about that though. We're gonna talk about that. So yeah, median is the middle data value. For an even set of data values, meaning that you're gonna have two of them in the middle, you have to add them together and then divide by two. It's like you're averaging those two middle numbers. Yeah, and divide by 2. Yeah. All right. Not so bad, right? All right. Do, do, do. All right, y'all gonna have to help me out with this one right here. All right. So, what do barbecue flavored potato chips cost? According to the Consumer Reports, right, volume 66, number 5, the prices per ounce in cents of the rated chips are 19, 19, 27, 28, 18, and 35, right? What is the median? 19? Okay. How'd you get that? Mm-mm. That would be the range. We didn't talk about that, but we're gonna get to that.
Wait, can you give us a chance to put it in order?
Mm-hmm.
Hold on.
Yeah. Yeah. And don't worry, when you forget all of this, it's on your formula sheet.
I'm gonna see, I gotta go.
But it is pretty. I mean, I look at it and gives you the line, I still. No, no, fuck, you don't tell you that.
Nah. But she gives you the formula though, you know? Yeah. So like in the question is like, all right, here are these numbers right here. Find the median. All right, you don't remember what it is. Click on the formula sheet where it says median and you're like, okay.
I have a question, in this case. Are we having two medians?
And what do you do when you have two?
So I added 27 plus 19 is 46, and then 46 divided by 2 is 23. Yeah.
Good. Done. All right.
That just made me hungry.
Right?
Every time I get something, I'm sorry, guys. I'm just always hungry. Shut up.
That's not a bad thing. So just because my handwriting is not as pretty, right? To find a median, we first order the data and then note that there are an even number of entries, right? So the median is constructed using the two middle values. So we put them in order 18, 19, 19, 27, 28, 35. We know that 19 and 27 are the two middle numbers, right? And see, we could just like knock out these and then that's what's left, right? We add them together, divide by 2, we get 23. Boom. All right. So that's telling us the median price of the potato chips. All right. Mm-hmm. No. Really? It was mad easy, right? And I'm complicating it. I got you. Yeah. He did? Yeah. Yeah. Yeah.
It was the equal numbers, but it wasn't like this versus
Yeah.
like 5 lines of numbers.
Oh yeah, 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 yeah. But we did that already. That was like 2 weeks ago. Yeah. When we had to find like the frequency table and all of that. And
This?
it's related to that. Good. How you doing? Yo, you came just on time. We talking about barbecue potato chips. Yeah. Yeah. Hey, I'm right there with you. I ain't get to either. Yeah. Huh? Ramen, that'd be nice too. Yeah. At City College, they got an actual ramen shop. It's very nice. Yeah. All right. So according to Consumer Reports, the brand with the lowest overall taste rating costs 35 cents per ounce, right? Eliminate that brand and find the median price per ounce of the remaining barbecue flavored chips. Again, order the data. Note that there are an odd number of entries now. So the median is simply just the middle value, right? 19, right? Yeah. Just the middle. So how you find it, you just kind of, after they're in order, you just kind of knock out, knock out, knock out, and whatever's left over. All right? Nice and simple. To be honest with you, like 50% of your test is this.
So.
Mhm.
Right?
Huh? Oh, the other 50 is the stuff that we did before. You know? Yeah. Yeah.
No, yeah, not, actually, Natalie.
I mean, she probably know everything already.
I think I did that one.
Yeah.
Okay, well, don't.
She did the homework, that's why she knows. You know?
I don't remember.
Yeah. Yeah. All right. So 1 ounce of potato chips is considered a small serving. Is it reasonable to budget about $10.45 to serve barbecue potato chips to 55 people? It's not. We should have more. Okay. All right.
My budget is.
Because we know that the middle value of them is 19 cents per ounce. All right.
Are we gonna divide 1045 by 19?
Well, we can multiply it by it, right?
19.
Or no, we could divide it by 19, right? To see how many servings, right? Right. Mhm. Right. So yes, since the median price of the chips is 19 cents per small serving, this budget for chips assumes that there is plenty of other food, right? Because you divided by it. So how many times does 19 go in? So 55, not 55 to $10.45. We want to know, is that enough chips to serve 55 people?
With the decimal, decimal completely until we're done.
Just divide it with a decimal. I would do 10.45 divided by 19. Whatever. 10.45 divided by 19.
35 people, that's 95.
So wait, what's the answer that you got?
I just try to do like,
Okay.
do it faster.
I got
So I
you.
did 19 times 5. Oh, thank you. Right? And then you got 5 cents left over, not enough.
But how many? So 5 was the answer that came out.
95 cents, so it's like a dollar. I'm gonna round it up to dollar. For every dollar.
But not 95 cents, 19 cents. Like a penny less than 20. Yeah. Yeah. Mhm.
Okay.
But in the calculator, when you.
0.19 times 5. Yeah, yeah. Yeah.
Skip off this to the third number and you put the 5 there and then you put take away 99. Is that what you said? No, I didn't do it.
But what we're assuming here is that one person eats like an ounce of chips. Right?
So.
Yeah. Right. I can't think how many chips is an ounce though. Like I'm like really trying to think in my head. Wait, how many chips is an ounce? Yeah, yeah, it's not bad.
So
Yeah.
95%. Right? Sometimes an hour and a half. That's not bad.
Wait, you said a bag is what?
1 hour. A little more.
A bag of chips is an ounce. So that means that you should have like 9 ounce.
If not, I would have done it on calculator.
That's fine. That's fine.
It's around there, right?
Yeah. Let's think like your European style. Because they eat like nothing. So yeah. They taste their food, they don't eat food, you know? Yeah. Yeah. Exactly. Everything. They salt and pepper everything. That's it.
Sorry, I don't season myself.
Yeah.
Like, so I think sofrito.
You know that they had to learn how to do that. For years they never do that. Mm-hmm. Yeah.
Sofrito.
Yeah.
That with a small combination of seasonings.
That's pretty nice.
Yeah.
That's smart. That's smart.
Like,
Yeah. Yeah. See? That's all math right there too. That's all math right there too. Yeah. All right, let's get back to this. Sorry, look. So yes, since the median price of chips is 19 cents per small serving, this budget of chips assumes that there's plenty of other food. The median uses the position rather than the specific value of each data entry, all right? So if the extreme values of the data set change, the median usually does not change. right? This is why the median is often used as the average for house prices. If one mansion costing several millions of dollars sells in a community of much lower priced homes, the median selling price of homes in the community would be affected very little, if at all. Right? Because it's right, it's the position of where the number is. That's what you're using to as a measure of central tendency. The numbers?
So you figured from that position.
Yeah.
That.
That the average price is about 19. Pretty much. You know?
I'm trying to connect it.
So basically, like, because 19 is in the middle, I'm calling that the center of all the chip data, so to speak. Right? I could have used the mode, but that wouldn't have been a good representation, right? Like the median is just basically using the center.
Okay, okay, for example, if I did have my calculator, because I'm not really in the mood to solve paper right now. If I did have my calculator and I entered 745 divided by 19, I would have gotten 55.
Yes, 0.55.
0.50, okay, that's fair.
I don't know. Let me see.
So I'll be okay.
Did it agree? Yeah.
Yep, I got 55. So that is 55 flat. So everybody would have a bag basically.
Yeah.
You know? Yeah. Mhm. I see my mind just went like right in the gutter when I looked at the word ounce, like some the chips became something else for a second. Yeah. You know, we talking about nickel bags now and all that. Right? 35 cents now? Oh shit. Yeah.
Unless you put two.
Oh, right? Like, no, I'm with you right now. I thought we was in left field. The healthy chips. 35 cents. Yeah. Like you ever go to the supermarket and then like the chips that's like right at your eye level is the one you see on commercials all the time. And then you look up and you like, I don't even know what that is. And you look down like, I don't know what that is either. Right? Those be the healthy chips that we supposed to eat. You know? Yeah. 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 And the air. Yeah, the air costs money. Yeah. Mhm. Mhm.
Yeah, we use first.
Right.
That's from the, you know,
Mhm.
say that, okay, they're cheap. Readers can still look at they, Internet is one of the only companies, that still use the original recipe. So.
Really?
It's like $4.29.
I didn't know that.
Expired, like, hey, you won't give them 2 for $5. I will give them free.
Yeah.
Yeah, especially the chocolate donut.
Yeah. I would just ask them like donate it. Like, listen, y'all know y'all about to throw it out. Just yeah. Huh?
Boring, mom, I only find guys.
Me too.
That's not bad. I like apples and bananas and mangoes and all that. Mhm.
Very good point.
Mhm.
You're supposed to.
Yo, facts. Facts. Hard facts on that.
My daughter to like numbers like very soda, you know what I mean? Like I'm gonna have to make that choice. I like to go now. We go to McDonald's. Like, yeah, you know, girl, buy her a soda machine. Make your own. That's so cool. And then
They do have one. That's true.
like what I
That's
swear
true.
with my phone is I feel like an orange. I have an induction, so I had to lose my own sugar. Yeah.
and water, and then I thicken it up, make it my own syrup, and then I make my carbonated water, and then I pour it in there, and that's how that goes. I have a soda machine, a juicer.
That's so cool.
Wait,
Yeah,
you know
just
what I
yeah.
know now? I don't know the amount of stuff that they put in the stuff that we eat. It's crazy. And they constantly saying that all these different diseases and stuff is hereditary. It's not.
It's
our
not.
environment.
Yeah, it's our.
You know what the thing is? Like the way that we buy food by the weight.
Yeah.
You know, so when they put all this other stuff in it, it makes it heavier. So you can sell the same thing they used to sell, you know, at the same price, but really you only really selling half of the quantity of it. You know, yeah,
Yeah.
very illegal. Yeah. Mhm. Yeah.
What the government did was they put a tax on sugar, butter, and eggs and cream. So a lot of these companies don't wanna pay for that.
Yeah.
So they use other additives and other things. You notice the cakes are small. They don't use that. What makes the cake rise to the occasion? Butter, milk, and eggs.
Yeah.
Eggs make a cake.
Yeah.
Thing.
Yes,
They don't use none of that. It's all syrup.
Yeah.
you notice, but like
Yeah.
I don't eat McDonald's anymore. But I think the ice cream with the shakes, the milkshakes at McDonald's, that's not milk or ice cream.
No. You know who you're thinking about? You're thinking about Dairy Queen.
Is it Dairy Queen?
Dairy Queen, yeah. They don't put enough like fat or something into it. So it's not considered ice cream. Yeah. Yeah. Really?
Yeah, I don't eat.
I like McDonald's. Like, yo, their unsweet tea is fire. Yo, yeah. And yo, that dollar coffee. Wait, that's no. That's some real fancy stuff. I would love that. I'm not gonna lie. I would love that. Okay.
That shake, because they milkshake's made out of custard.
Oh, but that sounds delicious.
I love that type of thing.
See, I never had Shake Shack before. Now I gotta go try it. Yeah, I never had it. Yeah, huh? Yeah. That's a sugar that's in the milk. Yeah.
However, they stomach can't take that sugar.
Yeah.
That's in the milk.
Yeah.
Yeah.
I'm sick of
Yeah.
something that's too sweet. That's why I don't drink soda no more. Yeah. I can't find
Right.
it.
All right, let's look at this real quick. Note, for small order data sets, we can easily scan and set to find the location of the median. However, for large order data sets of size n, for example, it is convenient to have a formula to find the middle of the data value. So this is the formula right here. For an ordered data set of size n, the position of the middle value is going to be n plus 1 divided by 2, right? For example, I'm gonna give you a baby data set, right? Say, I got you, actually. Say I had 5 numbers, right? 5 numbers. And I plugged it into this formula. It would be what? 5 plus 1, which is 6 divided by 2. So that's 3, right? So what does that tell you? That's telling you that the third number, after you put it in order, of course, the third number, that's the median. So it's literally telling you where the median is. That's what this formula is. All right. Let's say, right. So let's say, for example, you had 99 numbers. Then the middle number is 99 plus 1 divided by 2, or the 50th number. That's where the median is, right? In an ordered data set. If you had 100 numbers, now we're talking about an even data set, right? If you had 100 numbers, right, then 100 plus 1 divided by 2 is 50.5. This tells us that there are 2 middle numbers in a data set, and the 50th and the 51st are those 2 middle numbers, right? So we're going to have to add those 2 in particular together and divide by 2.
Again?
Right. Or to find the median for that data set. Yeah.
This is so confusing.
Why?
When you add this
Mhm.
formula, just why?
You don't have to use it. This is just telling you where the middle number is. Yeah. Yeah. Right. Yeah. Right. No.
So this is the
If you-
same thing as
yeah. It is the median, yeah, but this is telling you where the median is. That's what this formula is. If you don't want to know where it is, you can just put it in order and then just like pop, 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 pop until you get it to it. That's fine. Yeah.
No, no, I'm sure.
Yeah.
A long, professor, actually, so long that we have no choice but to use this for me.
It's optional.
Uh,
You could spend the whole time on the test like finding it. That's fine. You know? All right. Let's get to the easy formula that everybody knows. All right. So, oh yeah, that one too. That one too. I got you. So an average that uses the exact value of each entry is the mean, sometimes known as the arithmetic average, right? So to compute the mean, we add the values of all the entries and divide by the number of entries, right? This is what everybody knows. So here it is. The mean is equal to the sum of all the entries divided by the number of entries, right? On your formula sheet, this is how the mean looks, right? It's called X bar, and it is the sum of X divided by N,
wait, that.
right? And what is
The
the,
squiggly line on top means me.
yeah, this means mean. Yeah. Right? And what you see on the formula sheet, sigma x right here, it means this. It means the sum of all the entries divided by the number of entries.
So sigma x also means me.
Hmm?
Okay.
No, sigma x over n is the mean. Yeah. The number of entries. Like how many numbers did I have in there? Right?
Yeah, this is
Median in the
important.
middle and the mode is,
The number that appears the most often.
you didn't go over the mode yet.
Yeah, we did that already. Yeah.
How do you?
Good question.
What is the?
No, that's the mean. Yeah, that's the mean, the sum of all entries divided by the number. Oh, yeah, that's the mean. Yeah.
So how about this? All right. To graduate, Linda needs at least a B in biology. She did not do so very well on her first three tests. However, she did well on her last four. Here are her scores, right? Probably shouldn't be letting y'all see it, but it is what it is, right? So 58, 67, 60, 84, 93, 98, and 100, right? She cheated on the last one. Anyway. So compute the mean and determine if Linda's grade will be a B between an 80 and an 89 average or a C, which is between a 70 to a 79 average. All right. So go ahead, do it. Y'all could do that for this class too if y'all want. Matter of fact, I should put that question on y'all next test, right? Right? Like yo, like calculate your final grade for the test for the class. You know? Alright. Good, good. Mhm.
So you want.
So find the mean.
Oh, yeah.
80, good.
Our testing quizzes will be y'all pair up. And if y'all fail, y'all.
Yeah.
Okay.
But you really want to fail with everybody, you know?
We figure it out.
'Cause you already know you're gonna get an A, right? So I'm just saying you want to fail with everybody.
From first class.
Y'all don't need it though. Y'all seen the questions already. You seen the question.
You can see where we at. People are.
But y'all good. Like honestly, I'm looking around the room. I feel like everybody here gonna get an A, maybe except her. But other than that, like, you know, like we good, you know? Yeah. Yeah. Especially her.
No, fair.
She bored, man. Like, yeah. Right? Yeah. They already doing work. They already doing like next week homework, Uh, they doing next week's homework right now.
I'm not a good touch taker at all. They used to pull me out of class, take tests, but
Yo, so why you didn't apply for it in college?
they used to take that like in middle school.
Yeah.
But I used to do good, I just needed more time.
Yeah.
It's like a good test taker, like I freeze, especially word problems.
Like I'm probably gonna rush you in the test and all that, but like, yo, listen, you only got 1 hour and 29 minutes left. Hurry up. Mhm. So that's it, just in the calculator, 5, 6, yeah. Mhm. Mhm. So here's our answer right here, right? So the mean is the sum of the scores. You just add them all up, divided by how many tests she had, which was 7, right? So 560 divided by 7 is 80. So since the average is 80, Linda will get her needed B. Yay! Now she can go to nursing, right? So for real, that's like half your test, so you're good. All right. So when we compute the mean, right? We sum the given data. So there is a convenient notation to indicate the sum. Let X represent any value in the data set. Then the notation sigma X here is read as the sum of all of the given values. All right. Go ahead.
Does that mean we multiply?
Add.
You're adding.
Yeah.
So when we add the sum of all numbers to get the mean, I'm lost.
You divide it by how much number is there.
Right.
Oh, you're just giving us another way to do the same
Yeah.
thing?
I'm trying to explain to you what you see on your formula sheet. Because your formula sheet says sigma X. It doesn't say like sum of X in English. But this is what it means. You're right. That's what it says. Yeah. Yeah. You're good. It's on the formula sheet, so you're good. Okay. All right. Da, 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 means that we are to sum all the data values. In other words, we are to sum all the entries in the distribution. The summation symbol sigma means sum the following and is the capital sigma, the S of the Greek alphabet. All right. So those of you that's going to join like your sororities and stuff and your fraternities, that's S for sigma, right? The symbol for the mean of the sample distribution of X values is denoted by X bar, right? That's the X with the line on top, right? X bar. If your data comprise the entire population, we use a symbol mu, right? Which is lowercase Greek letter mu, right? This is what it looks like. It looks like a U sort of thing, right? To represent the mean, right? Everybody remember that Pokemon? For real? You're a Digimon fan. No. Oh, Yu-Gi-Oh! It's time to do it. Let me stop. Yeah. I recently was rewatching the whole series. You know, there's so much that I missed out on. Mhm. What's that? Yo, I love that. I love that. Yo, I want to know. I want to know what happens after Korra though. I'm so tight. Like, what's gonna happen after Korra? Yeah, they make a new one. Yeah. Yeah. I still want to know. Yeah. I still want to know what happened to Aang after age 13. Like, yeah. Like we know he got grandkids, but nah. It's like ooh, yeah, he has grandkids, but I'm like, what happened on the way to grandkids? Like, they kids even dated, like Toph's kids and Hank's kids were dating and all that, you know?
I didn't rewatch Korra. I only
Yeah.
once and that's it, but.
Really?
But the Avatar, I rewatched it.
Korra, like the first season was fire, and then the next couple of seasons, it got like it,
Stale.
not stale, but it wasn't as Avatar-y, so to speak. I don't know.
It's just not as much.
The ending was fire though. Like fire. Mhm.
I like that we wasn't getting the same thing over like
Yeah.
bending,
Yeah. Yeah.
bending.
Mhm. I like how like it just that bending style just like went like it just carried into like the future. I like that part. All right, let's talk about the procedure to find the mean. Okay, appreciate that. Thanks. All right, so how to find the mean. This is how you find it, right? You want to compute sigma x, right? That is to find the sum of all the data values. Step two, you want to divide the sum total by the number of data values. So the sample statistic, x bar, is x bar is equal to the sum of x divided by n, right? The population parameter mu is equal to the sum of x divided by capital N. Capital N means that you have the entire population. Lowercase n means that you only have a sample, right? It's the same formula. Don't.
A big N, little N.
Yeah, it's all on the formula sheet. N is your sample size. It's how many entries you have. Yeah. Yeah.
Was trying to do, this is a nightmare.
Yeah. Really? It's simple.
Girl, and
Yeah.
you
Yeah.
and it's been different.
Yeah.
Like a break-
Plus, this is gonna be on YouTube later. Do you like it? Mhm.
Yes.
Uh-huh. Yeah, no, it's the same thing. Every question is gonna be the same formula. It doesn't change. So when I say what is the mean, this is it. Add all the numbers, divide by how many numbers is there. That's it. Yeah. Mhm. Exact same thing. It could be a decimal. That's fine. Yeah, that's fine. Yeah. Yeah.
Which I should take on that bike, but.
All right, let's take it up a notch. Right. Mm-hmm.
Cause these words be probably tricky as hell. They do that, say certain things and it's like.
It's all the ones like with the homework. Yeah. So y'all good to go.
Some questions, it'll say divisor, and then it'll say what denominator. So divisor, I'm dividing.
The divisor is the denominator.
So it's the same thing.
Yeah.
So I should be dividing nothing.
You should be. Yeah. Yeah.
This is for.
Mhm.
Okay.
So let's take it up a notch, right? What do averages tell us, right? So an average provides a one number summary of a data set. Huh? Yeah, right. So the mode tells us the single data value that occurs most frequently in the data set. The value of the mode is completely determined by the data value that occurs most frequently. If no data value occurs more frequently than any other data value, there is no mode.
Yeah.
Period. Right?
The last number that the
Right. The specific values of the less frequently occurring data do not change the mode. All right. The median tells us the middle value of the data set that has been arranged in order from smallest to largest or largest to small, whatever. The median is affected by only the relative position of the data values, right? For instance, if a data value above the median or above the middle two numbers of the data set with an even number of data is changed to another value above the median or the median itself, it does not change, right?
quick question, so like if there's an odd number of numbers.
Yeah.
Like 9.
Yeah.
There can't technically be a middle, so there's.
There is the middle number.
There's
Yeah.
only the middle one is.
Yeah.
When it's an even number.
Oh, you're right, you're right.
Because-
Yeah. Yeah.
So
But
you get,
what this is saying though, right, is like, let's say I had a data set and then I decided, you know what? I'm gonna change one of the numbers in the data set, right? I'm gonna make it bigger or smaller, right? It doesn't change the median
no,
itself, right? Because the median is based on the position,
position.
where it is, not what it is, you know? For the mode, though, right, it's still the number that appears the most frequent.
Can you give us an example?
I got you. Yeah, there's more coming.
Yeah.
So the mean tells us the value obtained by adding all the data and dividing by the number of the data. As such, the mean can change if just one data value changes. On the other hand, if data values change, but the sum of the data remains the same, the mean will not change, right? So let's say I take out 2 from this number and put 2 into another number, the mean stays the same,
Yeah.
right? That's what that's saying. Right. Good stuff to know.
It makes sense and then again it doesn't, but I'm trying to follow.
I got you. I got you. As long as y'all understand the basics, y'all good. The whole half of your test right here. All right. So we have seen 3 averages: the mode, the median, and the mean. For later work, the mean is the most important. A disadvantage of the mean, however, is that it can be affected by exceptional values, outliers, right? If you have a number that's too big or too small, that could affect what the mean would actually be. Okay. Yes, because they're part of the data set, you know? So like, yes, we all make $70,000 a year, but the one CEO over there that makes 2 million, he's still part of the company. So we gotta add him, you know? But his salary throws off the average of all of us, you know? No, you include it, you know? Yeah. So the thing is that when you have like, let's say like she's trying to apply to get to our company, right? She thinks that like, oh, people over here get paid, but really and truly, we're not paid like that. He just makes mad money, right? So when she looking at her numbers, she's like, yo, y'all is living, and then she come to meet us and we're like, nah, for real, like we can't even supersize it at McDonald's, yo, like. Yeah. All right, now we about to take it up a notch. Mhm. There's something interesting right here. So a resistant measure is one that is not influenced by extremely high or low data values, right? The mean is not a resistant measure of the sensor because we can make the mean as large as we want by changing the size of only one data value. The median, on the other hand, is more resistant. However, a disadvantage of the median is that it is not sensitive to the specific size of each data value. Okay. Right. Right. So a measure of sensor that is more resistant than the mean, but still sensitive to the specific data value is called a trim mean. All right. So a trim mean is the mean of the data values left after trimming a specific percentage of the smallest in data values from the data set. Usually a 5% trim mean is used. This implies that we trim the lowest 5% of the data as well as the highest 5% of data. And then a similar procedure is used for a 10% trim mean, right? So this is how you do a trim mean real quick. So how to compute a trim mean? Order the data from smallest to largest, right? Delete the bottom 5% of the data and the top 5% of the data. If the calculation of 5% of the numbers of the data values does not produce a whole number rounded to the nearest integer, now compute the mean with the remaining 90% of the data. Right? Yeah, we're gonna do it. But like, just to talk about it real quick, right? All right, so remember, she's trying to join our organization, right? But now she got information, she got everybody's salary here, right? So we got the one CEO over here who's making like like 1 million, right? We all over here making 70,000, right? But low key, right? Let's say like your baby, right, is actually part of our organization, like doing an internship, and like she the lowest paid out of all of us, but she's still part of it, right? So what she could do now to decide if she wants to join us is perform this trim meet, right? So she would eliminate the CEO salary and eliminate like your baby's salary, right? And then just look at our salary together in the middle.
So the even.
Right. So then now she'll have a more clearer picture of what the average really is, you know?
Oh. Yeah, I really
Yeah.
need you to write.
So like, let's write this one, the last one we did,
Mhm.
and that was it, right?
Right.
Take 5 from 58
Exactly.
and 5 from 100.
Well, you take those two numbers out and then you just do the middle of it
Okay.
as an average. Yeah. Yeah, and then you just do the middle. Yeah. I got you. That's what you want to do. Yeah. Mhm. Which one? With like the bimodal or something? Like uniform? You mean like that?
Yeah, it was yesterday.
I guess. I guess a little bit. I guess. Yeah. Like I'll tell you how's it go? They did this experiment in my college, City College, where I went after this. What did they do? They were trying to see if a flipped classroom was better than a regular classroom, right? A flipped classroom. So the way a flipped class works, right, is like the teacher would give you all the information, right? Like you have your reading, you have your homework, you do it, and then you come to class, and the only reason you come into class is to ask questions. Like the kind of like basically like the teacher doesn't teach at all. They like you literally just they're literally just here to answer your questions from homework, and that's it. Right? That's a flipped classroom versus having yeah, versus having a teacher who comes in and they're writing on the board and all of that. Right? They actually did this with the calculus class in City College. Right? So here's the funny thing, right? When they did the average of it, right, the of the flipped class versus the regular class, there was no difference. The same number of people that failed in the regular class failed in the flipped class as well. But then they did a trim meet, right? When they did the trim meet now, right, the middle portion of the flipped class was higher than the middle portion of the regular traditional class, right? Why is that, right? You have some people in class, right? Like this one, where no matter what class they're in, they're gonna get an A. It don't matter. They could have the best professor, they could have the worst professor. They're gonna get an A, right? Then you have some people where it doesn't matter what class they're in. They could have the best professor, they could have the worst professor, but something in their life is going wrong, and that's going to cause them to get an F, right? So so how do you know which class is better? You want to know what's happening to the middle portion of students that's actually taking the class. So you eliminate the super A's and you eliminate the super F's. And whoever's left in the middle, how is that average? You know?
Everybody is not.
Yeah.
Really.
Right. There's some people who are really, really good students. No matter what situation you put them in, they're gonna get an A. You know, think of like the valedictorians, right? Like they have no complaints about no professor. Like they just gonna get an A. You know? Yeah. You know? Yeah. Right. You know, so but that's the power of the trim mean. This is why we want to look at trim means, right? Mhm. But let me explain a little bit more before we jump into it. Oh, we gonna get to that. Uh, it can be.
But if we, I'm confident.
Mm-hmm.
You know what, I'm sick of FedEx and I'm sick of UPS.
I feel you.
Left them a whole note.
Yeah. So in general, right? when a data distribution is mound-shaped symmetric, remember that from yesterday? Mound-shaped symmetric. The values for the mean, median, and mode are the same or almost the same. For skewed left distributions, right? The mean is less than the median, and the median is less than the mode. For skewed right distributions, the mode is the smallest average, the median is the next largest, and the mean is the largest, right? So let's take a look at what those are looking like, right? I'm going to show you the three different distributions. So, right. So I'm tying in like yesterday and today real quick. All right. Oh, but it makes sense though. It's gonna make sense. Look.
Sure.
So if you have like a symmetrical set of data, you have as many like big numbers as you have small numbers, right? Mound shape, symmetric, right? Like this. All three of them is gonna fall in the middle, the mean, the median, and the mode, right? It's gonna be a very accurate measure of central tendency, right? They're not gonna be the exact same number, but they're about the same, right? But when you have skewness now we have to have a different conversation when it comes to skewness. Uh-huh. Yeah.
It's gonna be what? There's no numbers there.
I'm just saying in general, they're gonna be about the same in the middle.
Oh, I'm sorry.
Yeah,
It's confused because there's.
yeah,
And then we put.
yeah. Like I'm just generalizing it, like that. Yeah. A mound shaped symmetrical graph. Right? Yeah, go ahead. Yeah.
Right? This is the left part. This is the right one.
Yeah.
No, we're getting to that. We're getting to that. So like let's look at this one now, right? So this is skewed left, right? Let me make it a little smaller.
Because the tail is on the left, right?
Exactly, right? So in the skew left, right? Notice that you have a mean, mode, and median, but look at how they're distributed, right? The mode is the highest, right? The median is a little bit smaller than the mode, but still larger than whatever the mean is, right? This is skewed left, all right? Let's take a look at skewed right, because skewed right is actually different as well, all right? So this is skewed right. And make it a little bit smaller. Gotcha. So this is skewed right. So again, it's different though. This is skewed right. So there is a mode and a median and a mean, but this time we have the mode is still the largest, right? The median is there, but the median is bigger than whatever the mean is. Yeah. So skewed left versus skewed right. Right. All right. The next thing that we're gonna talk about, this is what y'all really wanna know about right here, right? If anybody want to know like how I get that A in the class, how I get that B in the class, right? This it right here. This is called the weighted average. All right. So sometimes we wish to average numbers, but we want to assign more importance or weight to some of the numbers. For example, how your homework is 37% of the class grade, right? All right. For instance, suppose your professor tells you that your grade will be based on a midterm and a final exam. That's a hard class, each of which is based on 100 possible points. However, the final exam will be worth 60% of your grade, and the midterm grade is only 40%. How could you determine an average score that would reflect these different weights? The average you need is called a weighted average. So this is so the weighted average is equal to the sum of the individual number times its weight divided by the total number of weights. All right. It's not a formula sheet. Yeah. So where X is the data value and W is the weight assigned to that data value. So the sum is taking over all of the data values. All right. Fun stuff, fun stuff. All right. Let's look at an example real quick. Because I feel like this will make more sense. It is? Why? I didn't even get to measures of variation. That's okay. Y'all will live. Y'all learn that next week.
So
Hmm?
an example of today's homework.
We did. We're gonna do the last one. Look, weighted average, right? Suppose your midterm test grade is 83, your final exam score is 95. You're using the weights of 40% for the midterm and 60% for the final. You want to compute the weighted average of your scores. If the minimum average for an A is a 90, right? Will you earn an A? That's the question, right? So, y'all want to try it or y'all want me to just go through it? All right. So by the formula, we multiply each score by its weight and add the results together, then divide by the sum of all of the weights, right? So, huh?
That's like a good picture.
I got you.
83.
So, right. So 83, that was your what? Your midterm test score. And 40% of your grade is the midterm. So that's why you have the 0.40. 95 was your final exam, like test score, and 60% of your grade is coming from the final. That's why you have the 0.60. Right. So we're gonna multiply those and add those together. Then we're gonna divide it by the sum of the weights. 0.40 and 0.60 when you add them together is 1. So this is a little bit easier than that. So all you do is you finish the math. 33.2 plus 57 is 90.2. So yes, you will get an A in the course.
Like 60 are considered like cents.
Right.
And then it makes
Because
it
because it's like 40%. So to change a percent to a decimal, you write the whole number and divide it by 100. And then that's how you get the 40% and the 60%, right? As a decimal.
Divided by 1 is 90.
Yeah.
I don't think I'm gonna be able to do homework a lot.
To change a percent to a decimal, you take the whole number of the percent and divide it by 100. That's how you get the decimal for
Or
it.
you could just add.
You can just move it too. That's another thing as well. Just move it 2 units to the left.
But if it's 300, that's
Yeah.
2, right? Or doesn't matter.
300 would be 2, yeah, to the left, yeah.
You sure?
So that's it. Next class, we'll talk about variation. All right.